Let's now learn about how to draw covalent Lewis structures. So earlier with ionic Lewis structures, we had to draw a naked and a stuffed metal and nonmetal. But covalent structures are electrons that are being shared, so they look a lot different. Okay? So certain facts is that all atoms, all our nonmetals want 8 electrons, and there's 2 exceptions. Hydrogen is happy with just 2 because it can look like helium, and boron is happy with 6. So you got to remember these 2 exceptions. Don't be a high moron. Remember hydrogen and boron. Those are your 2 exceptions. So once again, covalent compounds are when a nonmetal bonds with another nonmetal. All right, so let's learn how to draw these. Let's start with the CH4. So if you look on your periodic table, carbon is in the 4th column, so it has 4 valence electrons. Hydrogen is on the very first column, so it has only 1 valence electrons. So I'm going to draw some tiny versions of these Lewis structures. So carbon has 1, 2, 3, 4. And hydrogen has 1. So if you look at the compound over here, it says we have 1 carbon and 4 hydrogens. So I'm going to draw another hydrogen, another hydrogen, and another hydrogen. All right, so how can we rearrange our carbon and hydrogen so that they're sharing electrons and everybody's happy because they have 8 electrons, or hydrogen here gets 2? Well, anytime you see a lone little electron here, so this is all the dots on carbon are very lonesome, then what you can do is you can pair them with a buddy. So for example, this can pair up over here, this one can pair up here, this one can pair up here, and this one can pair up over there. So let's think about what that looks like. If I were to rearrange it into a beautiful fashion, we could say carbon that had 4 is now attached to this hydrogen, attached to this hydrogen, attached to this hydrogen, and attached to this hydrogen. And we show that they are sharing those electrons by putting a dash between them. So a dash here, dash here, dash here. So as you can see, each dash sort of represents 2 electrons. So you have an electron here and you have an electron here. So that's 1, 2, 3, 4, 5, 6, 7, 8. So carbon now has 8 electrons and hydrogen has 2. So hydrogen gets these 2, carbon gets all of those 8. So everybody's happy. Okay, so let's look at another example. Another example on to the right-hand side is BF3. Okay, so boron is in the 3rd column, so it has 3 valence electrons. And fluorine is in the 7th column, so it has 7 valence electrons. The compound is BF3, so let's draw this carefully. I'm going to draw boron that has 1, 2, 3 dots. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. There's 3 fluorines, so I'm going to draw another one. 2, 3, 4, 5, 6, 7. There's another fluorine. 1, 2, 3, 4, 5, 6, 7. Okay, if you look carefully here, you can see that these electrons, and these electrons all have a friend already. Like these have a buddy, these have a buddy, and these have a buddy. This one has a buddy, this one has a buddy, and this one has a buddy. So all your lonesome dots are the ones that are going to be paired up, right? So that they can share electrons. So this lonely dot is going to friend this lonely dot. This lonely dot's going to find this lonely dot, and that lonely dot's going to find this lonely dot. Okay, so if we were to redraw this in a prettier way, because this is basically everything up here, scratch work. We have a boron, right, that normally had 3 dots, right? And then it's going to connect with fluorine's lonesome dot here, fluorine's lonesome dot here, and fluorine's lonesome dot over here. Now, all the red dots that I circled earlier can't be forgotten, okay? So you got to put them back on fluorine. So it's got to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now, if you count, okay, so boron gets 1, 2, 3, 4, 5, 6, which is what boron wants, because boron is an exception. Boron likes to have 6. Now, if you count fluorine, okay, so I'll just count that in a different color here. Fluorine gets 1, 2, 3, 4, 5, 6, 7, 8. And each of the fluorines get 8 dots. So everybody is happy because now we are sharing electrons so that everybody can have 8. Okay, so let's do more here. Here is Br2, okay, bromine bonded to another bromine. Bromine's in the 7th column. 7th column, there are 2 of them, so I'm going to draw them. Bromine has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So here all our paired electrons already have a friend, so I'm going to take this lonely electron and make it a friend with that electron. Now we want to redraw it because this is all scratch work. It's not very pretty looking, so I'm going to rearrange it. So bromine had 1, and it's going to share it with another lonesome bromine over here, and you can't forget those other dots. So all those other dots, right, that already had friends, here, 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 and here, you can't forget about them. So you want to draw those dots over here. Oops, let me make sure I can draw those dots. Right, so if you were to count it really quick, then you would see that it would be 1, 2, 3, 4, 5, 6, 7, 8. And same thing on the other side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so everyone's happy. All right, so let's do another example. Here's O2. Oxygen is in the 6th column, so it has 6 valence electrons. There are 2 of them. All right, so let's draw oxygen. So that's 1, 2, 3, 4, 5, 6. Here's another oxygen. 1, 2, 3, 4, 5, 6. All right, so you got to pair up all the lonely electrons. So here's a lonely electron, and here's a lonely electron. Okay, these already have friends, so we don't mess with them. Now we're going to redraw it so that it looks better. So we're saying this oxygen had these 2, and this oxygen has these 2, and they are going to be shared. Okay? So how many electrons are being shared here? 4 electrons are being shared between them. And now we're going to include all the other dots that already had buddies. Right? So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now both oxygens are happy because 4 of them right here belong to both of those oxygens. All right, great. Let's go down here to HCl. Hydrogen is in the 1st column, chlorine is in the 7th. Here we see we have 1 of each, So hydrogen has only one valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. We pair up the ones that are lonely, which is lonely with lonely. We redraw it so it's nice and pretty. So H is going to share with Cl. And then all the ones that had buddies, we have to not forget them and draw it. 1, 2, 3, 4, 5, 6. Right, so chlorine gets 8 on this side, and hydrogen gets these 2 as well. So there are 2 electrons that are being shared between them, right? So hydrogen gets 2 and chlorine gets 2. So that's how chlorine has a total of 8. Hydrogen prefers to only have 2. So now everybody is happy. All right, last example, Ni3. All right, nitrogen's in the 5th column, and iodine is in the 7th. It's Ni3, so I'm going to draw 1 nitrogen. 1, 2, 3, 4, 5. And then 3 iodine. So I have 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so iodine already has a lot of friends, but there are still some lonely ones. So let's find the lonely dots here. And now we can redraw it in a nicer form. So nitrogen is going to pair up with an iodine. Nitrogen is going to pair up with another iodine. Nitrogen is going to pair up with another iodine. And nitrogen here, if you look carefully, already had some friends there. So I'm going to include those there. And then all the dots around iodine. So if you forget all the dots, you do get points taken off because that means iodine doesn't have a full 8 unless you draw these dots. All right. Perfect. So now we're going to learn something called Vesper, and that's on the next page. So let's learn about what Vesper is and how we can apply it to the pictures that we just drew. Vesper is short for valence shell electron pair repulsion theory. Basically, the key word here you want to focus on is repulsion. Okay, electrons do not like other electrons. Okay, basically Vesper is the shape of a particular covalent compound because electrons do not like other electrons. Okay, so quick reminder once again, when you have a nonmetal with a nonmetal, that is a covalent compound. Covalent compounds have shape. Okay, so in order to learn what shape goes with which compounds, we have to understand some vocabulary terms. The central atom is the least electronegative atom in the molecule. Basically, in easy terms, the fewest number of this atom is usually the central atom. So for instance, if you have BF3, the fewest number is usually the central atom. So you have 1 boron and 3 fluorines, then boron is going to be in the middle, central. You have 2 hydrogens and 1 oxygen. That means oxygen will be in the middle. You have 1 carbon and 4 fluorines. Then carbon is going to be in the middle. Okay? Lone pairs are unshared electrons. So they're basically all those dots that already have friends, right? They don't participate in a bond. So they already have friends, so they're not going to share, they're not going to hold hands. Okay? So, for instance, boron is in the 3rd column. So if I draw boron, 1, 2, 3, none of those 3 have friends, so they have 0 lone pairs. Now, Fluorine is in the 7th column. So if I were to draw fluorine, it would be 1, 2, 3, 4, 5, 6, 7. Now if we look here, okay, we can see that they have friends here, here, and here. So how many lone pairs do we have? We have 3 pairs of unshared electrons. Remember, they have to come in a pair like this, okay? 3 unshared electrons. All right, carbon's in the 4th column, so it's 1, 2, 3, 4. There are no lone pairs here. None of these have friends already. Oxygen is in the 6th column, so it goes 1, 2, 3, 4, 5, 6. So if you look here, there's a pair here, there's a pair here. So how many lone pairs do we have? 2. Okay, now that we understand this, now we can understand our 5 Vesper shapes. Now let me just say there are tons of shapes, but we only are going to learn the main 5. Okay? So, first question you want to ask yourself is how many elements are bonded to the central atom? So whichever one's in the middle, how many are attached? Okay? If there's only one attached, right, then there's really not a central atom. So you don't have to ask yourself about the lone pairs. That means the shape is called linear because it creates a line. So here, if you're just attached to 2 things, like here's one thing and here's the second thing, you can't help, like math, 2 points create a line, okay? Now, if your central element is bonded to 2, okay, then the question you ask yourself is, on the central atom, is there a lone pair? Meaning that, does it have some electrons that already have friends? If the answer is no, then it also creates a line, so we call it linear. It just creates a longer line. So look at the picture next to it. Okay? Now, if the answer is yes, there are friends, there are lone pairs on our central atom, then the shape becomes what we call bent. It literally has a bent shape. So if you look at the picture here, you will see that it bends down at a certain angle. All right, if you are attached to 3 of them, okay, and there are no lone pairs on our central atom, we call it trigonal planar. Now this should be easy to remember because tri means 3. Planar means that it's flat, okay? So it creates a very flat shape, okay? Now, if the answer is yes, there are lone pairs, we have a different name for it. It starts out the same. It's trigonal. So once again, that tri meaning 3. But what happens is that instead of being flat, okay, the middle central atom gets sort of lifted up and it creates a pyramid shape. But we call it pyramidal. Okay, there is an all AL here at the end. But it creates a pyramid shape because that central atom is going to lift up and now it creates that pyramid. Okay, if you're attached to 4, we're not going to have any lone pairs for sure. We call this shape tetrahedral. You should be familiar with tetra because tetra means 4. Okay, let's use this to apply it to the shapes that we learned over here. All right, so you have some questions to ask yourself. The first question we want to ask ourselves on this one right here is, how many elements is the central atom bonded to? Well, our central atom is carbon. it's attached to 4 hydrogens. So we know that this shape must be what? It must be tetrahedral. That is the only shape that is attached to 4. All right, the next example here, you're going to ask yourself, okay, our central atom is boron. Here's boron. It's attached to 3. Does boron have any lone pairs? Do you see any dots that were already friends? No, because we see here that this was shared, and this was shared. Okay, so if the answer is 3 and no, then the shape must be, so let's go back here really quick. Whoops, right here. If the answer is 3 and no, it must be trigonal planar. Okay, now let's apply it to these next 4. Here, if you look at this example, we see that there is no central atom. Because there's no central atom, it creates a single line, but we call it linear. Okay. The next one as well, there is no middle element. So this also creates a line, so we call this linear as well. This next example also has no middle element, so this one is also linear, creates a line. Now this last one, it's attached to 3. Okay, we have our nitrogen here being our central atom. It's attached to 3, but you can see that it does have a lone pair. It does not share electrons. So if you look at your chart, 3, yes, it has lone pairs, then what shape do we call it? We call it trigonal, and it's going to pull up and create that pyramid dull shape. Perfect. So now, on the next practice, what you're going to be doing is practicing drawing your Lewis structures and telling me what shape corresponds to the drawing that you just drew. Right?